Good morning, children. So let's continue discussing the fourth chapter, that is linear equation in two variables. So today we will discuss about the equations of line parallel to x-axis and y-axis. So equations of line parallel to x-axis and y-axis. So let us consider a linear equation where x minus 2 is equals to 0. So this is a linear equation in one variable. As we can see, only one variable is there, that is x. The other variable is not there. So therefore this we can rewrite it as x equals 2. So it is treated as an equation in one variable, that is x, as I have already told. Hence it can be represented as a point on the number line. So this one we can represent on a number line directly. So that means, so this is the number line. That means actually this is the x-axis. Since it is only the value of x-axis is given, the y-axis is not there, so therefore we can treat this one as the x-axis. We can write as x dash x. So and this is a number line, so directly we can represent this is the point 2, that is from 0 1 2. So this is the point 2. The same equation, that is x minus 2 is equals to 0, can be rewritten as x plus 0 dot y. That means 0 into y minus 2 is equals to 0. We can rewrite this equation in this manner. So that is x plus 0 into y minus 2 is equals to 0, which is treated as an equation in two variables. Now this becomes the equation in two variables. As we can see, two variables are there, that is x and y. Hence it can be represented on a Cartesian plane. That means how we have represented earlier, that means in a Cartesian plane. We can draw the graph of this. So let us take some points. That is, if we take the value of y as 1, since it is 0, we can take here any value, it will become 0 since it is multiplied with 0, since the coefficient of y is 0. So we can take, suppose we take 1. So if the value of y is 1, then 0 into 1, it becomes 0. So therefore the equation remains as it is, that is x minus 2. So therefore the value of x will be 2. Again, if we take here minus 2, it becomes 0. So again the value of x remains same, that is 2. Again, if we take 0 here, so again the value of x remains same, that is 2. So that means no matter what value we take here in place of x, it becomes 0, and in place of y it becomes 0, and the value of x remains same as it is, that is it remains x is equals to 2. Now let us plot this point on a Cartesian plane. So if we plot this point on a Cartesian plane, we can see the value of a is 2, 1, that is 2, 1. In x-axis it is the movement of 2, in the y-axis it is a movement of 1. So this is the a, that is 2, 1. B, so the value of b is, in x-axis it is 2, in y-axis it is minus 2, therefore this is b. Again the c, in x-axis it is 2 and the y-axis it is 0, there is no movement in y-axis, it is 0. So this is the point C. If we join these points, we get a straight line, and this straight line, as we can see, it is parallel to y-axis. So this straight line is parallel to y-axis. That means from this we can conclude one thing, that if x is c, which is a constant, here in the question it is given that x is equals to 2, that means 2 is a constant. So if x is equals to constant, that means the value of x is fixed, then we get a line which is parallel to y-axis. Then we get a line which is parallel to y-axis if the value of x is fixed, that is 2. Similarly, we can write, if the value of y is fixed, that means if the value of y is a constant, then we get a line which is parallel to x-axis. We'll get a line which is parallel to x-axis. So therefore these are the conditions where we find that the equations of the lines which are actually parallel to x-axis and parallel to y-axis respectively. So let's move to exercise 4.4. It is given, find the geometric representation of y is equals to 3 as an equation in one variable and in two variables. That means we need to find the geometric representation of this. We need to represent this in one variable, as an equation in one variable, and as an equation in two variable. So we already know, that means in one variable we can represent it on a number line, that is this is the value of y is equals to 3, 1 2 3. So this is the value of y is equals to 3. So in two variables we will be representing this on a Cartesian plane. So to represent this on a two variable, we need to rewrite the equation since x is not there. So we can write x, that is 0 into x plus y. So that means the coefficient of x is 0. So 0x plus y is equals to 3. The points which satisfy the above equations are tabulated below. So here we can take any value of x and the value will be 0. So that means the value of y will remain same, that is 3. So first if we take the value of x as 2, that is 2 into 0, it becomes 0. So therefore value of y remains same, that is 3. So if we take the value of x as 0, that is 0 into 0, 0, and the value of y remains same, that is 3. So now let us plot this on a Cartesian plane. So as we can see, this is the value of a, that is on the x-axis there is a movement of 2 and on the y-axis there is a movement of 3. So therefore this is a 2, 3, and b, as we can see, 0, 3. So in the x-axis there is no movement and in the y-axis there is a movement of 3, that is 0, 3. So if we draw a line through these points, we can see that this line is parallel to x-axis. As we have already mentioned at the second point, that if y is constant, then we get a line parallel to x-axis. So here in the question it is given y is equals to 3, that means y is constant. So therefore we obtained a line which is parallel to x-axis. So that means this condition is satisfied. If y is constant, we get a line which is parallel to x-axis, and if x is constant, then we get a line which is parallel to y-axis. Then question number 2, it is given that twice x plus 9 is equals to 0. So in one variable twice x plus 9 is equals to 0, we can rewrite this as twice x is equals to minus 9. That means the value of x will be minus 9 by 2. That is, we can write x is equals to minus 4.5. In one variable, we can represent this directly on a number line. That means since this is the value of x, so therefore we can obtain this on a x-axis. Okay, so therefore this is the value of x, that is minus 4.5. As we can see, this is 1, this is 2, this is 3, this is 4, and this is 4.5, which is in middle of 4 and 5. It is 4.5. That means here we have taken it as 1 centimeter, so therefore 4.5, so it is 0.5 will be 5 millimeters. Now in two variables we can rewrite this equation since y is not there. So we can write like this: 2x plus 0 into y plus 9 is equals to 0. So therefore the points which satisfy the above equations are tabulated below. So points which will satisfy these equations are tabulated below. If we put the value of y, we can take any value of y, it will become 0 obviously, and the value of x remains same, that is minus 4.5. So if we take the value of y as 0, so 0 into 0, it becomes 0, and the value of x remains same, that is minus 4.5. If we take value of y as 2, so 0 into 2, that is 0, and the value of x remains same, that is minus 4.5. So let us plot this point on a Cartesian plane. So if we plot this on a Cartesian plane, we can see that this is the value of a. That means on the x-axis there is a movement of 4.5. So this is minus 4, this is minus 5, so this is 4.5 between minus 5 and minus 4. So this is the point A, and the point B, it is given that minus 4.5 and comma 2. So therefore in the x-axis there is a movement of 4.5 and in the y-axis there is a movement of 2. Therefore this is the point. So if we draw a line which passes through A and B, we can see that this line is parallel to the y-axis. So this line is parallel to y-axis. Why this line is parallel to y-axis? As we already know the condition. If the value of x is constant, that means if the value, here we can see x is equals to minus 4.5. So here the value of x is constant. So therefore we obtain a line which is parallel to y-axis, which is already given. If value of x is constant, then we get a line which is parallel to y-axis. So with this we have finished this chapter, that is chapter 4, linear equations in two variable. So that's all for today. Thank you.